Hello students, welcome back to the Tantray Sir physics classes. Today I have come up with one more additional problem, challenging problem on circuits involving inductor and a capacitor and a resistor and DC source, right? So the question is like this: in the circuit the key is closed for a long time. The key is already closed and the current has been flowing for quite some time. Suddenly the key is opened at t is equal to 0. Now the key is opened suddenly. Find the maximum charge on the capacitor. What will be the maximum charge on the capacitor when you open the key? That is the question. The key was already closed and the current was already flowing in the circuit, and all of a sudden at t is equal to 0, we open the key. We open the key and then we have to find what is the maximum charge accumulated on the capacitor. That is our question. And the values are given: E is 50 volts, resistance is 250 ohms, L is 2 millihenry, and C is capacitance 20 microfarad. So this you have to remember: what is the voltage, what is the resistance, and what is the inductance value, and what is the capacitance value. Okay, now this is a question that we have to solve. We have to finally find how much is the charge, maximum charge accumulated on the capacitor, and why should there be the charge accumulation on the capacitor. That is also we have to see. Okay, now how much is the charge accumulated on the capacitor? First of all, it sends current like this. Current flows through the inductor and current flows like this. There's no current initially through the capacitor. Why? Because when the current flows for a longer period of time, this inductor is a short. There is no flux change in the inductor, so there's no induced EMF. So it is just a wire. So current is bypassed like this. Current will not flow through the capacitor. So what is the initial voltage on the capacitor? Initial voltage on the capacitor is 0, because this point and this point are at the same potential. No potential difference between this point and this point, or this point and this point, because it is a short, and current flows through this short in this circuit. And what is that current? That current is through the inductor, just E by R. Equation number first. Because when this is short, the current has been flowing for quite some time, and current has already achieved a steady value, and that current is just E by R because it is short, it is a wire equivalent. Okay, and the inductance, the flux in the inductance will always oppose the change. The moment you try to increase the flux through the inductor, it will oppose that. The moment you try to decrease the flux through the inductor, it will oppose that change. It will produce the induced EMF in such a way as to oppose that change. Okay, the current has been flowing. Now all of a sudden what you do, you open the key. Now the current through this inductor, the current cannot flow now through this path. The current flows through the capacitor path. So the circuit will now be like this. The circuit will now be like this. This is inductor through which current I flows, and now this part of the circuit is cut and the circuit is closed through the capacitor like this. So initial current I, that is this, because when you cut the circuit, current becomes 0 from here, but the current through the conductor is the same, because the inductor finds another path for the current to flow. So initial current at t is equal to 0. At t is equal to 0, current is equal to E by R. Now the current starts decaying. It starts decaying through the capacitor. So the current flows through the capacitor. Now when this is opened, the current flows through the capacitor and it charges the capacitor. It charges the capacitor. So, and current starts decaying in the inductor. In the inductor, current will decrease, but at the same time it will charge the capacitor, and finally the capacitor will be fully charged. The moment the capacitor is fully charged, the current through the inductor will become 0. The moment the capacitor is fully charged, the current through this circuit becomes 0. जब ये कैपेसिटर पूरा चार्ज हो जाएगा तो current will become 0. Obviously, then current will flow in the reverse direction. So it will oscillate. Basically, current will oscillate back and forth. But we have to find what's the maximum charge on the capacitor. By the time there's a maximum charge on the capacitor, by that time the current through the inductor is 0, or current even through the current through the capacitor is also 0, because when the current is 0, it is 0 in the circuit, it is 0 in the complete circuit. So current through L is 0, current through C is 0 once the capacitor is fully charged. So what concept we are going to use to find the maximum charge on the capacitor? What is the concept that we are going to use? The concept that we are going to use here, okay, the concept is that at t is equal to 0, where current through the inductor was maximum, there was energy stored in the inductor. And that energy stored in the inductor, when current flows and it gets charged and the current in the inductor becomes lesser, the energy in the inductor will decrease. But at the same time, the energy in the capacitor will increase because it gets charged. And when the capacitor is fully charged, that the energy in the capacitor will be maximum. But by that time, the energy in the inductor will be 0. So energy will be conserved. Energy is being shifted from the magnetic energy to the electrostatic energy. Initially, the energy was stored in the inductor in the form of current or in the form of magnetic field. But finally, when the current decays and the capacitor becomes fully charged, the magnetic energy goes, but it now is stored as the electrostatic energy in the capacitor. That's all. So it's the energy conservation. Initial energy was in the form of magnetic field, and final energy is in the form of electric field in the capacitor. So what we write, initial energy is the energy in the inductor, that is 1 by 2 Li square plus capacitor energy, that was 0. That was 0. Because initially the capacitor was not charged. Final energy, that is the capacitor energy, that is 1 by 2 C, capacitor's value, Q square, when it is fully charged by the charge Q, plus it is electrostatic energy, but by the time there is no energy left in the inductor, that is plus 0. Magnetic energy plus electrostatic energy. Final energy is electrostatic energy plus magnetic energy. Finally, there will be no magnetic energy, it will only electrostatic energy. Initially, there was only magnetic energy, no electrostatic energy. But the total energy has to be conserved. So what we write is that EI is equal to EF, energy conservation. Energy conservation. Now, when I equate the two, so what I will get? 1 by 2 Li square is equal to 1 by 2 C Q square. 1 by 2 cancels. So what should I write for Q? What should I write for Q? Okay. क्या लिखेंगे Q के लिए? तो यहाँ Li square is equal to 1 by C Q square. So what is Q square? The energy maximum charge stored in the capacitor, square of that, it's LC I square, right? So what is Q? That is I root of this and root LC. Okay, now what is Q maximum charge on the capacitor? It is I, that's E by R, as you know, as we already find it, E by R. Initial current in the inductor was E by R, current E by R, root LC. Q equal to, what was E? That we already know. E was equal to what? 50 volts, R is 250, L is 2 millihenry, and C is 20 microfarad. Substitute all these values. It is E, that is 50 by 250 root, what is L? That is 2 into 10 raised to power minus 3 Henry, because it is millihenry, and 20 microfarad. It is 20 into 10 raised to power minus 6. So it is cancels off 5. So Q is equal to 1 by 5 root of, it is 4 into 10 raised to power 9 and 8 minus 8. So it will be Q equal to 1 by 5 into 2 into 10 raised to power minus 4 when we get it out of the root. So Q equal to 1 by 5 into 2 into 10 raised to power minus 4 coulombs. These are coulombs. And if I multiply by 10 raised to power 6, it becomes microcoulomb. Right? So that's Q equal to, it is 200 by 5 is equal to 40 microcoulombs. That is the answer. So the question was, the current was already flowing through the inductor. The current through the inductor was maximum initially because this switch was already closed for a longer period of time, and there was already a steady current in the inductor. The inductor was short. There was no potential difference between this point and this point. So voltage across the capacitor was 0 initially. But when you cut off this connection, key is opened, at that time what happens? The high current through the inductor will not be 0 immediately, because it has a different path to follow. It will follow through the capacitor path and will charge the capacitor. So the current will decay, but at the same time it will charge the capacitor. So it shifts this magnetic energy to the electrostatic energy. So energy will remain constant. So this magnetic energy is called electrostatic energy. By the time the current is 0, by that time we have the capacitor fully charged, so it has an electrostatic energy. So initial magnetic energy is equal to final electrostatic energy. When you equate the two, then you get the maximum charge on the capacitor. Thank you. This was 23rd challenging problem for the students who want to go for the IIT or JEE or for the Physics Olympiad. Don't forget to watch my lectures on the YouTube. Thank you.